Yes, students, in today's session we are going to understand about the Kelly-Hamilton's theorem, characteristic equation, and the eigen's value, that is the roots of this characteristic equation. So let us know what is the statement of this Kelly-Hamilton's theorem. It states that for every square matrix A, there exists a constant lambda. Where lambda is a constant, such that it satisfies the characteristic equation, that is determinant of A minus lambda I, where I is the identity matrix. So this is the characteristic equation, we say characteristic equation. So in general also we can write the characteristic equation as some example with that you can write. When we get the example we will come to know. So this is the statement of CS theorem. Now let us take the problems on this CS theorem. In short we say it as the CH theorem also. CH theorem. In short we say it as a CH theorem. We have taken the problem on CS theorem, that is to find the characteristic equation and characteristic roots of the matrix A given by 2, 0, minus 1, 3. So to start with, we have to write the CH characteristic equation is A minus lambda I is equals to 0. This is the characteristic equation. It is general one, but you have to write suitable to this matrix. You have to convert it in another way. That is, A is what here? A is 2, 0, minus 1, 3, minus lambda into. In this we are putting the values. A is what? Lambda and I. We are putting in this. So that is 1, 0, 0, 1. It is equals to 0. Its determinant value should be 0. Then you have to continue further multiplying lambda with this 2, 0, minus 1, 3, minus 1 into lambda is lambda, 0 into 0 is 0, 1 into lambda is lambda. Determinant value should be 0. Next, we have to minus these two matrices. That is equals to what? 2 minus lambda, you have 2 minus lambda, and 0 minus 0 is 0 itself, minus 1 minus 0 is minus 1, 3 minus lambda is 3 minus lambda equal to 0. Cross multiply this and this here, what will you get? 2 minus lambda. 2 minus lambda into 3 minus lambda, cross multiply. Minus 1 into 0 is 0, and this is equals to 0. Same you have to write. 2 into 3 is 6. Minus 2 into, it is minus here. 2 into minus 2 lambda is minus 2 lambda. Minus lambda into 3 is minus 3 lambda. Minus lambda into minus lambda is plus lambda square minus 0. You need not write that equal to 0. So arrange them in the proper manner. Lambda square first. Minus 2 lambda minus 3 lambda is minus 5 lambda and plus 6 is equals to 0. So this is the characteristic equation. Here it is not write equal to, already 1 equal to sign is here. So that's continuation. You can write implies, this implies like this, you can write. This implies like this. This is what is the characteristic equation of the given matrix A. Now to solve for this, what are the lambda values? As there is a square here, we will be getting 2 values, unknown values, lambda, 2 values we will be getting. By factorization method, we are getting this. So, eigen's value, that is the roots, minus lambda square minus 5 lambda plus 6 is equal to to 0. Now to go back, factorize this. What will get again? The same step will be get here. What are the multiples of 6? 3 into 2. So we want minus 3 plus minus 2 equal to minus 5. So I have to write here lambda square minus 3 lambda minus 2 lambda plus 6 is equal to 0. And finally, here lambda is common. So what remains? Lambda minus 3 remains. Here plus minus 2 is common. So lambda here minus 3 here. So equal to 0. Minus 3, lambda minus 3, lambda minus 3. This is in one bracket, lambda minus 2, lambda minus 2 equal to 0. Separate the equal thing to 0. This is also 0, this is also 0. Lambda minus 3 equal to 0, lambda minus 2 equal to 0. So lambda is equal to 3 and lambda is equal to 2. So these are lambda 1, lambda 2 you can say. Two values of lambda are getting. So these are the roots or eigen's value also we call. Eigen's value is nothing but the lambda values. Okay. Yes, we are taking another sum of the same type, that is to find the characteristic equation and characteristic roots. Okay. Same way, like A minus lambda I is equal to 0 is a characteristic equation. Is a characteristic equation. So assume this. Next in this we have to write what is A, what is I and all. So here continuing, it implies that A value is 1 minus 1 minus 6 minus 2 and minus lambda into 1 0 0 1, that is equal to 0. Now that implies to minus these two. So first multiply this. That is as it is 1 minus 1 minus 6 2 minus 2 as it is minus lambda 0 0 lambda equal to 0. Only have multiplied here, nothing much. Now to minus these two matrices. That is 1 minus lambda, this 1 minus lambda, minus 1 minus 0, minus 1, minus 6, 0. That is minus 6 here. Minus 6 0 is minus 6 itself. Minus 2 minus lambda, minus 2 minus lambda equal to 0. Minus 2 minus lambda is equal to 0. Now cross multiply. This and this have to cross multiply. 1 minus lambda. I take this minus common here outside. What remains here? 2 plus lambda remains. Minus 6 into minus 1 is plus 6. But formula is minus, so 6 here equal to 0. Then minus, keep outside the bracket, multiply these two. 1 into 2 is 2, 1 into lambda is 1 lambda, minus 2 into lambda is minus 2 lambda, minus lambda plus lambda is minus lambda square, and this minus 6 is equal to 0. So this is a characteristic equation. So it is still here, minus common is waiting outside to multiply. Check the sign above. So further, minus lambda square, let me write this minus outside still. So this is 2 minus lambda plus lambda is minus lambda and minus lambda square minus 6 equal to 0. To take this minus inside, minus into minus plus lambda square, minus into minus plus lambda minus 2 and this minus 6 is equal to 0. What I did? I multiplied by minus inside all the elements. So lambda square plus lambda minus 2 minus 6 is minus 8 equal to 0. Now this is characteristic equation. This is a characteristic equation. This is what is a characteristic equation. characteristic equation. Now we have to find the roots of this equation, that is Eigen's value. Eigen's value. We have to find the Eigen's value. So here you have to compare this with ax square plus bx plus c equal to 0. This and this equation you compare, and what is ABC you have to write. Here a is 1, b is also 1, and c is minus 8. C equal to minus 8. So either formula you have to write here. It is x equals to minus b plus or minus square root of b square minus 4ac upon 2a upon 2a. Okay, that is equals to minus b is 1 here plus or minus square root of b square is 1 square is 1 itself minus 4ac. 4a is 1, c is minus 8 whole upon 2a. 2a is 1 again, that is minus 1 plus or minus square root of 1. 4 8 is 32, minus into minus plus 32. Okay, plus 32 whole upon 2a is 2 itself. That is equals to 1 plus or minus root of 33 upon 2. So now there are two values. What is lambda 1? What is lambda 2? Lambda 1 is this, lambda 2 is this. That is with plus 1 lambda 1, with minus 1 that is lambda 2. That is 1 plus root of 33 upon 2. 1 minus root of 33 upon 2. Like this we have two values of the lambda. These are called as Eigen's value or characteristic roots also. Of the roots simply also roots we say. Okay. Students, we are taking another problem of the CS theorem, the Cheyle-Hamilton's theorem. As you know, characteristic equation is determinant of A minus lambda I equal to 0. Put the A matrix A, lambda and identity matrix, multiply by this lambda inside of this, and subtract both the matrices, and cross multiply, we will get this equation. Simplify. 5 into 1 is 5, minus 5 into minus lambda is minus 5 lambda, lambda into 1 is minus lambda into minus lambda is plus lambda square, plus 6 equal to 0. Now lambda square minus 5 minus lambda is minus 6 lambda plus 11 equal to 0. That is, now I have to find the roots. This is the characteristic equation. It is one part of the problem. Equation, characteristic equation. So that is a characteristic equation. Now I have to find the roots here. Let us see the formula to apply. ABC value from this you have to write, and then what is B, 4AC etc. to write. B is minus 6 minus into minus 6 plus or minus square root of B square. Minus 6 square is 36 minus 4, A is 1, C is 11 whole upon 2A, 2 into 1. That is equal to 6 plus or minus square root of 36 minus 44. 11 into 4 is 44 upon 2. That is equal to 6 plus or minus square root of 44 minus 36 is minus 8 whole upon 2. Now from this you can write lambda 1 as that is 6 plus square root of minus 8 whole upon 2, and lambda 2 you can write it as a minus square root of minus 8 upon 2. So these are the roots of this characteristic equation. That is the CS theorems. Eigen's value also we say. Yes, now we are taking another sum of the same type with different numbers. The matrix is 3 minus 2, 2 minus 1, and the characteristic equation is A minus lambda I equal to 0. Now you have to put the A matrix value. Simply steps are same here, only numbering is different. So cross multiply this, minus 3 minus lambda minus 1 minus lambda minus into 2 into minus 2 is minus 4 and minus plus 4. For formula minus will become here plus 4 equal to 0. Then multiply minus 3 into minus 1 is plus 3. Minus 3 into minus 1 is plus 3 lambda. Minus lambda into minus 1 is plus lambda. Minus lambda into minus lambda is plus lambda square plus 4 equal to 0. Now write lambda square. 3 lambda 1 lambda is 4 lambda. 3 plus 4 is 7 equal to 0. This is the characteristic equation. Now to find the roots of this. What is ABC value from this you have to write. A is 1, B is 4, C is 7. 1, 4, 7. So just formula or not, you have to write. Put the B, A, C value in this. Simplify. You will get this lambda 1 and lambda 2 values. This is the same type of sum you will be getting with different numbers every time. So since formula if you know, it is very easy to find the roots also. Okay. Practice more sums of this type by taking your own numbers in the square matrix. Okay. This chapter is completed till this CS theorem. This full 10 hours teaching is there of this matrices starting from the first session. 10 session altogether here. So you have to revise all the things properly and prepare the notes of this which are given in the PDF and to practice again by referring different textbooks or and solve the assignment question also. This which are given. Okay.